Howdy folks, welcome. In this video I'm just going to quick go through the practice test and again show you how I would go about solving the questions. I recognize it's by no means the only way, and in some cases it might not be the way that works best for you. If you have another way that works fine, that's perfectly valid. You can go ahead and use that, but this is just how I would go about solving the questions. Alright, so the first question here is asking us to simplify this exponential expression. So simplify the following expression, write in your answer with only positive exponents. So in this case we have z to the third, n to the third, all divided by z to the negative sixth, n to the 11th. Alright, so again, the main thing we want to keep in mind is we want only positive exponents. And again, we can move these expressions, these exponents, on to either the top or the bottom. And when we flip sides, we just have to change the signs. So in this case, we want to have a positive z. So I'm just going to move this z from the bottom up to the top. And when I do that, again, I'm going to change the sign on the exponent. So it's going to change from negative 6 to positive 6 there. All right. And again, I want positive exponents. So in this case, 4 is bigger than 3. So I'm going to go ahead and move this n to the bottom. And again, when I do that, I just have to change the sign. So it goes from positive 3 to negative 3. All right. And then if I have two things that have the same base that I'm multiplying together, I can just add the exponents. So in this case, I'm going to have z to the 6 plus 3 over n to the 4 plus a negative 3. Which, just doing the arithmetic here, ends me up with z to the 9th over n to the 1st, or simply n. Z to the 9th divided by, okay, see, nope. Z to the 9th over n. Alright. So the next question here is dealing with a radical equation. So an equation involving square roots. So in this case, we have the square root of 2x plus 33 equals, or plus 9, equals x plus 8. All right, so your first step in solving these equations is you want to get it so you just have the square root all by itself. So to do that, I'm going to subtract a 9 from each side. So when I do that, I end up with square root of 2x plus 33 equals x minus 1. All right, and then once I have the square root by itself, I'm just going to square both sides. Because again, when I square a square root, the squared and the square root cancel themselves out. So I'm just going to be left with 2x plus 33 on the left-hand side. And when I square this, again, I do want to be careful that I don't distribute the 2 through. So again, when I square it, that means that I'm just multiplying it by itself. So so just to make that explicit and so that I don't forget that I can't distribute the 2 through when I'm adding or subtracting inside here, I'm just going to write that out explicitly there. All right, so here we're going to have x squared minus 1x minus 1x plus 1. So we're going to put 2x plus 33 equals x squared minus 2x plus 1. All right. So then I want to get this in standard form. So again, standard form means I have everything on one side of the equal sign equaling 0 on the other side. So I can subtract the 2x from each side here and subtract the 33 from each side. So I end up with x squared minus 4x minus 32 equals 0. So at this point, I just have a quadratic equation, so I can use the quadratic formula. You can use the zero factor property, I think, in this case as well. So that's what I'm going to go ahead and do here. So in this case, I'm trying to find two things that multiply to get 32 and add to get negative 4. So that would be x minus 8 and x plus 4. And then again, we can just set each of these equals 0. So we end up with x equals 8 and x equals -4. All right. So yeah, so in these questions, it is important that you go back and make sure that they work within the original expression. So yeah, so if we plug in 8 here, so we have 2 times 8 plus 33 plus 9 equals 8 plus 8. All right, so 2 times 8, that's going to be 16 plus 33 is 49. Which square root of 49 is 7, which 7 plus 9 does equal 16. So x equals 8 works. All right, so then we just got to check for -4 here. So you have 2 times -4 plus 33 plus 9 equals 8 plus -4. Or I guess -4 plus 8, sorry. So we had 2 times -4 would be -8 plus 33. So 33 minus 8 would be 25 plus 9 was -4 plus 8, which would be 4. So the square root of 25 is 5, which 5 plus 9 does not equal 4. So that means -4 does not work. So my answer is just going to be x equals 8. So yeah, so sometimes you may end up with the answers that work here, but when you plug them in, don't necessarily work. All right. All right. So yeah, so the next one is it's asking us to multiply these polynomials here. So you have 7x squared plus y times x squared minus 3y. All right, so you have 7x squared times x squared, so that's going to be 7x to the 4th. And then we have 7x squared minus 3y, so that's going to be minus 21x squared y. And then we have y times x squared, so that's going to be plus 1x squared y. And then we have y times -3y, so that's going to be minus 3y squared. Which then we can combine these two like terms here. So you have 7x to the 4th minus 20x squared y minus 3y squared. X to the 4th minus 20x squared y minus, nope, what? Minus 3y squared. Ugh. These are so annoying. All right. All right, so the next one is looking at solving a absolute value equation. So here you have the absolute value of 14y plus 5 plus 8 equals 4. All right, so the first step in solving an absolute value equation is you want to get the absolute value all by itself. So here we're going to subtract an 8 from each side. So here you have -14y plus 5 equals -4. Which again, remember the absolute value is a distance. And in mathematics, distances can never be negative. All right, so that means that the absolute value can never be a negative number. So yeah, so the values for y that make this, this whole thing equal a -4, there's no value for y that makes it a -4. So yeah, so in this case, there is no solution, or the empty set. All right, so the next one here, so you have x to the fifth to the -3rd, and we're asked to simplify the expression, write the answer with only positive exponents. All right, so yeah, so first, if we have an exponential expression that we're raised to a power, we can multiply the powers. So yeah, so here you'd have 5 times -3, which would be -15. All right, and again, we want this to be written with the positive exponent. So again, we can change which side of the fraction bar this is on, and when we do that, we just have to change the sign on my exponent. So yeah, so I'm just going to bring this guy down. So we're going to end up with x to the positive 15th in the denominator. So we have 1 over x to the 15th. 1 over x to the 15th. All right, so the next one here. So we have 8x minus 6 squared minus 25 equals 0. All right, so we're asked to solve this using the square root property. Again, I don't really care which method you use to solve these quadratic equations, but in this case, the square root property is probably the best method to use, since again, we have something involving our variable squared equaling a constant value. So yeah, so first we can move the 25 over just by adding 25 to each side. So you have 8x minus 6 squared equals 25. And again, to get rid of the squared here, we can just take the square root of both sides. And when we do that, we just have to account for the plus or minus root there. So again, the square root and the squared are going to cancel out. So you have 8x minus 6 equals plus or minus the square root of 25, which is 5. So we can add 6 to each side. Then divide by 8. So yeah, so an x is positive 5, so you have 5 plus 6 is going to be 11, so you have 11/8. And when x is negative 5, we have negative 5 plus 6 is going to be 1, so you end up with 1/8 there. So those are going to be my two answers. All right. So the next one here, so you have a rocket thrown upward with a velocity of 22 meters per second from the top of a 24-meter high cliff, and misses the cliff on the way down. So when the rock is 10 meters above the ground, so when will the rock be 10 meters above the ground? All right. So yeah, so I will give you a formula sheet. I have it right here. So yeah, so the main ones we'll need are the quadratic equations and projectile motion. The rest of these will come into play later on. All right. All right. So yeah, so again, we have h equals h naught plus v naught t minus 1/2 gt squared. That's probably a different, yeah. I'll stick with the order that they give in the sheet there. So we have negative 1/2 gt squared plus v naught t plus h naught. All right. And yeah, we have the rocket's thrown upward with velocity. So my initial velocity is 22 meters per second. All right. And my initial height is 24 because it's thrown up from a 24-meter high cliff. And in this case, since I'm using meters per second, my g is going to be 9.8. All right, and we're asked to find out when h equals 10. All right, so just plugging these values into our equation here, we end up with 10 equals negative 1/2 9.8 t squared plus 22 times t plus 24. So yeah, so you have negative 4.9 t squared plus 22t plus 24. All right, and again, I want to get this in standard form. I like dealing with positive leading coefficients, so I'm actually going to add or subtract these across to get to this side. That way I end up with a positive 4.9 t squared. But again, you can also subtract a 10 from each side. In fact, I think most of the time in class, I did it that way, so I'll do it the other way. So yeah, so I'll go ahead and subtract a 10 from each side here, just to show you that you can do that. That is allowed. All right, plus 22t plus 14. All right, so yeah, so when we have a decimal leading coefficient, that's generally when the quadratic formula is most often used, at least in my mind. So yeah, so again, the quadratic formula will also be on that formula sheet there. So again, that's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have negative 22 plus or minus the square root of 22 squared minus 4 times a, which is negative 4.9, times c, which is 14, over 2 times negative 4.9, so over 2a. Again, a is whatever your leading coefficient is, b is the middle coefficient, and c is your constant term in your expression there. All right. And I am out of room on this page. We'll just move on to the next page here. So yeah, so we got negative 22 plus or minus the square root. We have 22 squared minus 4 times negative 4.9 times 14. So I got 758.4 over negative 9.8. All right, so then we have negative 22 minus the square root of 758.4 divided by negative 9.8. We end up with 5.055. And when you have negative 22 plus the square root of 758.4, that divided by negative 9.8, we end up with negative 0.565. All right. Now, there's no mention of a time turner or police box or DeLorean with a flux capacitor. So yeah, so we can kind of assume that time travel is not going to be a thing in this question. So we can just kind of ignore that negative answer there. So we can't have negative time. All right. So yeah, so the only one, so yeah, so round says round it to 2 decimal places, so that would be 5.056 or 5.06 seconds. All right. All right, so the next thing it asks is for us to find the restricted values for the following rational expression. So your restricted values are when your denominator equals 0, so you can't divide by 0. So yeah, so to find the restricted values, we have 7x squared plus x cannot equal 0. And then it's just a matter of solving this quadratic equation. So yeah, so in this case, this can factor nicely. All right, and again, just like when we have it equals 0, we can do the same thing with not equal 0. So yeah, so we end up with x cannot equal 0 and negative 7. All right. All right, so the next one here, so we're asked to simplify this radical expression. So you have the square root of 48x to the 8th. All right. So yeah, so starting off, we can simplify this as square root of 48, square root of x to the 8th, so we can kind of separate our variable part from our constant part. So we can add just the constant parts, or we can for perfect squares that go into 48. So yeah, so again, your perfect squares are 1, 4, 9, 16. And 16 does go into 48. So yeah, so we can break apart this 48 into the square root of 16 times the square root of 3. And then here we can write this as a fractional exponent. So that would be x to the 8th to the 1/2. Again, when we have the square root, that's to the 1/2 power. So yeah, so when we take 8 times 1/2, so yeah, so I'll just start off by saying square root of 16 is 4. All right, then we have square root of 3. And then 8 times 1/2 is going to end up being x to the 4th. So yeah, so we end up with the expression 4x to the 4th times the square root of 3. Okay. How do I get the square root? Okay, fine. That was annoying. All right. All right. All right. So the next one here, so looking at solving a rational equation. All right. So to solve a rational equation, so first of all, you can factor every single one of your expressions. Simplify if you need to. In this case, we do want to keep in mind that we can't divide by 0, so we cannot end up with an answer of 0. So if you end up with x equals 0, we can either ignore that and just keep the other answers, or there's no solution if that's the only solution there. All right, and then when you have a rational equation, what you can do is you can cross multiply. So you can multiply across the diagonals and then set those products equal to one another. So you have x plus 1 times 5x equals 6x times x minus 3. All right. And then we can distribute these things through. So we have 5x times x, so that's going to be 5x squared plus 5x equals 6x squared minus 18x. All right. And yeah, so then we can get this in standard form. So we can have subtract a 5x squared from each side, subtract a 5x from each side. So we have x squared minus 23x equals 0. And then we can just factor this. So we have x times x minus 23 equals 0. And again, we just set each factor equal to 0. There. So yeah, so we end up with x equals 0 and x equals positive 23. But again, we said earlier on that we can't divide by 0, so x cannot equal 0. So we just ignore that answer, and we just keep the 23. And again, if you're ever curious as to whether you have the correct answer or not, you can always go through and check it in terms of the original question. So yes, when you plug in a 23 in for x, we end up with 24 over 6 times 23. We end up with like 0.1739 it's going to be some weird fraction there. So we have 20 divided by 5 times 23. We end up with the same decimal. So yeah. So if you're ever curious as to whether you have the correct answer or not, with these ones when you're asked to solve equations, you kind of have a built-in check that you can utilize there. All right. So next we're looking at a square root, simplifying the square root expression again here. All right, so again, I'm just going to separate everything into its, so we just have one thing to worry about in each part there. So we have square root of 3yz to the 22nd. So we can separate that in the square root of 3, square root of y, square root of z to the 22nd. These ones can't really simplify. There aren't any perfect squares besides one that goes into 3. But this last one here, so we can simplify that since we have an exponent that's bigger than 2 on the side here. So we have square root of 3, square root of y. And then just to simplify this, I'm just going to rewrite this with fractional exponents here. So square root of z to the 22nd is the same as z to the 22nd to the 1/2, which again, we may have an exponential expression that we raise to a power. We can multiply the powers. So you have square root of 3, square root of y, and then 22 times 1/2 is going to be z to the 11th there. So you end up with z to the 11th, and then we can combine these guys again underneath a single square root again. So you have square root of 3y. All right, so the next one here, so you have 3x to the third plus 4x squared equals 15x. So first I'm going to get this in standard form. So again, I'm just going to subtract the 15x so that we have everything on one side equaling 0. So you have 3x to the third plus 4x squared minus 15x equals 0. All right, and then we have a common factor of x that shows up in all these, so we can factor that out. So you have x, and then we have 3x squared plus 4x minus 15 equals 0. All right. And looking at this guy here. So again, we're looking for two things. So again, since we have a leading coefficient that's not 1, we're going to multiply that time as constant terms. So you had negative 45 here. And we want to add to get 4. So that would be negative 5, positive 9. So you have x. Then we have 3x squared minus 5x plus 9 minus 15, or my 9x minus 15. All right, and then we can factor each of these groups here. So again, we still have an x coming along for the ride here. All right. And then we have x shows up here, so we got 3x minus 5. And then here we have a 3 shows up in each of these terms, so we got 3x minus 5. So again, we can group the things outside parentheses and group the things inside parentheses here. So you have x times x plus 3, and then 3x minus 5 equals 0. All right, and again, you can just set each of these equal to 0. So you end up with x equals 0, x equals negative 3, and we got 5/3. So yeah, so those will be my 3 answers in this case. So we got 0, negative 3, and 5/3. All right, so next again, we're dealing with simplifying the radical expression. So you have the cubed root this time of 8x to the 4th, z to the 11th. So again, I'm going to start off just by separating everything into its parts here. So you have 3x to the 4th, and then we have the cubed root of z to the 11th. All right, so 8 is a perfect cube, so that's 2 cubes. So the cubed root of 8 is going to be 2. All right, and then the rest of these, I'm just going to go ahead and start off just by writing them as fractional exponents here. So you have x to the 4/3, and we have z to the 11/3. All right, which I'm just going to go ahead and write these 4/3 as mixed numbers here. So you have x to the 1 and 1/3, and then we'll have z to the 2 and 2/3. I guess, or 3 and 2/3, sorry. 3 goes into 11 3 times. There's 2 left over. All right, so then the whole number part of your mixed number here, that's going to be the exponent on your x, and then the fractional part, that's going to be the exponent inside the cubed root. So yeah, so here we have 2x and then we have z to the 3rd, and then we'll have the cubed root of x, of x to the 1st here, and then z squared, since the fractional part is a 2 there. So yeah, so we end up with 2x z to the 3rd times the cubed root of xz squared. All right. I think I need to pause this, need to run to class. So yeah, so I'll continue this later on. So yeah, so there'll probably be a part 2 then, I guess. So yeah, so hopefully you find this helpful. Yeah, have a lovely day, and I'll talk to you all later. Bye now.